Welcome back to the channel. Today we are building the possibly simplest antenna you can build, which is a regular half-wave dipole. We're doing that not because we want to use it for normal antenna things, but because we want to use that as a reference when we compare other antennas. Because when you quote a gain figure for an antenna, which is, I think gain is a bit of a misnomer, but all right. What you're talking about is directivity, the direction that the antenna transmits what it is transmitting. You compare that normally to either a dipole or what's called an isotropic radiator or an isotropic antenna. And an isotropic antenna doesn't exist, so you can't really build that and use that for a reference, but you can build a dipole, and it's also rather easy to do. So that's why we will build this. It's for, I'm going to use this for comparing antennas for LoRa APRS, which is on 433.775 megahertz, I think, yeah. And we will build it first. We will build it with elements that's way too long, and we will cut them to length after we assemble the antenna. There are too many variables, at least for me, to be able to figure out beforehand what's the correct length of the elements. The literature I found, I think most of it agreed on 16.6 centimeters for each quarter wave. But the way we're going to make this antenna is we're going to feed the coax all the way into the end of this, and we're going to bend the shield one way and the center conductor another way. So strictly, the antenna will start in the middle of this. Let's see if you can see this in the middle of this pipe. So if you make this 16.6 millimeters, you in fact have about 1 centimeter more of antenna inside, which is the remaining part of the coax. So it's not always as simple as it sounds, but what we can do is just make it, attach it to the analyzer, and we'll figure out from there how much we need to cut, and hopefully that's going to work. See, let's fire up the soldering iron here, and this is, it's not my favorite part of antenna building, I have to say. I'm not even sure if I can get... Yeah, it should work. I should be able to do that. Let's see if we can manage. You need a few 3D printed parts for this antenna. Really simple parts to print. And I've chosen a 20 millimeter PVC pipe for, let's call it the boom. That's long enough that I can actually hold it by hand, or I can mount it on a pole if I want to. So the antenna is going to be mounted like this at the end, and I can hold the other end to control the polarization, or I can mount it to a pole if I want to do something more repeatable. Also, I'm using these 3 ferrites for the choke. Can't remember what they're called, but that's going to be in the description, in the link. I'll try and zoom in. Maybe you can see more of what I'm doing. There we go. This is, of course, the center conductor for the SMA connector. That's going to be mounted at the end of the handle. There is also 3D printed parts available if you prefer to use a BNC connector. These will also be in the description, but I'm going to use this primarily for LoRa APRS, and basically all the LoRa boards that I have, they have SMA connectors on them, so I figured I'll just stick with SMA for this one. And when you look at that worked quite nicely. Still a little bit long, and one single strand of the center connector that insisted on making trouble, but let's see what we can manage. So let's see. start by thinning the center conductor. At least we'll try. Come on, be nice. Here we go. And with any sort of luck, that's still going to fit into this. Yeah, I think that works. We just need to heat that up. And hopefully, let's see, there's a little tiny hole. We might be able to get some more solder into it, and if not, then I think the amount of solder I already have here should be sufficient. Yeah, it should be all right. If you get too much on there, and it's going to get in the way when you insert it into the rest of the connector, but this looks rather nice, and it's in shot. Fantastic. So next up, I'm guessing, yeah, let's see if this works. Try to put that straight ahead, and see if we can get it sorted. No. Yes, can. And I don't know if you can see that, but let's see. Manage. Come on, focus. Yeah, you can see it there in the center. Very good. So I'm going to zoom out now. It's going to be a little bit easier to see the rest of whatever's going on here. So that's all right. We'll remove some of the shield, the braid, and we'll fold the rest down over the connector. Let's see if we managed. Yeah, a few more strands. And one more. There we go. Normally I'd be pretty screwed not having put this on in advance, but luckily this cable is rather short, so we can just thread it on from the other side and fold this braid over. And I never ever managed to cut it short enough, so I'll just roll it around a little bit to hopefully get most of it inside this little, I don't know what you call this, a ferrule maybe? See if we can force that over there, and we'll just use some side snips to remove the rest of it. Let's see. Yeah, I think that's good enough. Let's try and crimp this. Let's see if that works. And yeah, here we go. Let's see. I think that worked quite nice. Excellent. So next up, we might as well mount it into the tail end of the boom. This is gonna be mounted back here, and the connector is gonna stick out that end. So we'll just stick it in there. You see it's got a hexagonal hole to hold the nut, and I just need to find the locking washer and the nut. So we'll just screw that into place. Not too hard, this being 3D printed plastic. It's very nice. Let's see. It should be going like that, and once we get finished, we'll epoxy these two pieces together. So next up is drilling holes for this. This is a fiberglass, a little, maybe 10 centimeters stick of fiberglass. That's going to hold the radiating elements and insulate them from each other. This is 5 millimeters, and so there's a guide drill guide with a 5mm hole so that we get them on exact opposite sides. It's going to look a little bit nicer. Technically, it's not really important, but it's going to look a little better. So we start by taping this guide in place. Again, it's not really important that it's flush with the end, but again, it's probably going to look a little bit better if it is, so why not? I think that should be sufficient. And we need a 5mm drill. I've found that when drilling in the PVC, using, let's see if I can focus on this. Yeah, one of these wood drill bits actually work a little bit better, so you don't have to press. You don't have to press as hard to get through, and it doesn't deform as much. So let's see if we can manage this fairly straight. It looks all right. And the other one. Here we go. I could have used a drill press for this. We're going to need one for a few holes we're going to drill later on. But yeah, I figured this was easy enough to do without the drill press. So off with the guide. We can find the ends. Go. That looks surprisingly symmetric. I think this might be just a tad too big for this hole. Yes. So we will need a file to get it to the right size. Let's try this one. I think this is made for filing down metal, not PVC plastic, but hey. One more job to do with the cable, because this will be fastened at the end, and it will come up all the way to, you see this? Let's see, all the way to the hole, and it will split on either side of the hole, and I'll create a small hole to bring either the center conductor or the shield through the pipe, and we'll use a screw to connect them to the radiating elements just on the outside. See if you can visualize that. That's the plan anyway. So the important bit is to get the length of this wire just right. So I can see now that we'll have to cut the isolation at pretty much this point. So let's see if we can manage that. Away you go. Looks good. Yeah. And not to stretch the wire too much, I'll just cut there. There we go. So it's my least favorite part of doing anything with coax. It's separating the braid so that you can fold it off to one side. That's really, really boring. Let's see if we can zoom in so I can show you just how boring it is. If anyone has suggestions or better ideas of how to do that, then please do leave a comment. That's, as I said, it's probably my least favorite part of dealing with the coax. This is way too much braid, so I'm gonna lose some of it. So hope we can do that without breaking or cutting the grade we actually need. Let's see. Let's do this. Let's see what happens. Yeah, that looks about right. This should then just be enough to get through a small hole in the pipe that we haven't drilled yet. And we'll do the same for the center conductor. We'll just about 1 centimeter. This is about 2 centimeters in diameter. Inside diameter is actually 17 millimeters. So I guess half of the 17 millimeters we can leave of this insulation on the center conductor. We just eyeball that. I think the important bit is it's not short-circuiting inside the pipe. We should be safe with this amount, I think. Let's see if we can get this twisted nicely up. Well, there we go. Yeah. And we'll try and tin some of this. That looks good, I think. And we'll do the same with this. The nice thing on these is that you don't have to thin it all the way into the isolation. We're only doing this so that the strands doesn't separate. See if we can get some more of that tin off. Here we go. Good enough. So next up is figuring what size hole we need for putting these through on the side, either side of here. So well, I think a 2 millimeter should be all right. And sadly, I don't have a 2 millimeter. Sadly, I don't have a 2 millimeter wood drill bit, but we'll see if we can make this work. And we can. There's one. And the other. Let's see here. Now, I think for the most fiddly bit of this build, will be to get these wire ends through these small holes. It's going to be interesting. Let's see if we can find maybe we can use some tweezers. No, that's too weak. Try this stuff. If we can get them out here, you might be able to do a little bend, like so, and like so. That could make it easier. Are you seeing any of this? Zoom in. See, I'll create a little bend. And I'm going to try and poke that through this 2 millimeter hole. And it worked at least for one of them. Let's see if we can manage with the other as well. So that was a lot less fiddly than I feared it would be. And yeah, I think we should be ready now to insert this little fiberglass rod. See if we can manage. No. I think I need a hammer for this. See. There we go. Oh, this is so hard. And of course we forgot something. All right. As I said at the beginning, these are for choking, and these are for supporting the chokes so they don't rattle around inside the boom. And as you can probably guess, now it's a little bit late to put them on, so we will have to redo this, sadly. Let's see if we can get them out of there. Yes. And I guess these should be epoxied. Don't really bother mixing this up too much. So, for this job, the important bit is just that these stay inside the 3D printed housing. And let's put it that way. Yeah, for someone with my patience, that felt like forever, but it's probably been maybe 10 minutes. So let's try and put these ferrites with their, let's say, ferrules maybe, 3D printed things around them onto the coax. Come on. Go, last one. And I don't think fastening them are going to be really important, but I just want to put a little bit of tape back here so they don't slide backwards when I slide the coax into the handle or the boom. Should be plenty enough. Here we go. And yeah, let's get them in the right hand. Go and same tools to convince these little wires to go through the tiny 2mm holes. Yeah, this one. I have to say, I probably shouldn't say this before I do the last one, but this was a lot easier than I feared. And yeah, I shouldn't have said that because now the first one just disappeared back into into the boom. No, and it came out all by itself. That's fantastic. Let's see. Just pull them straight and see if we can find the little fiberglass pen. Put that back into place. About in the middle, like so. I think now is the time for the next glue up. We are going to glue the radiating elements and the front plug and the rear plug in place. So let's mix up some more epoxy and get that done. Let's hope that's enough. Let's see. Need some of this in here. Quite a bit, I would guess. Like so. And the other one. Let's see if we can get most of it in there. We go. And we just press these on, I think. Hope for the best. Yeah, with any sort of luck, that will do. And Let's just put a little bit more. Yeah, maybe even get a watertight seal. This antenna is meant to be used for testing, so it's not something I anticipate leaving outside in the rain, but couldn't hurt. Flip it over and do the same on the other side. I'd rather not have that. Yeah, why not? Let's try and fill the hole for the wires coming through from the coax as well. There we go, and let's do that one too. Yeah, there we go, and there's the front plug. There's no weight on this. This is not a structural part. It's just to make it look a little bit nicer. And finally, the back. See if you can see that. Something underneath there, not to mess up my work surface, and get some more epoxy on here as well. See if we can manage this. Should be plenty enough. Sadly, I now have to hold this in place. So I guess I will see you in about 5 minutes. Next up, we need to drill some holes to attach the coax to the radiating elements. And we'll try and do that on the drill press. Let's see. This is going to be noisy, so please excuse the noise. Yeah, let's see if let's get that on the overhead cam instead. We will try and use a file. That's a file down any burrs, and also to make sure at least maximize the chance of getting a good connection between the coax and the radiating elements. Let's see, I need to do this on both sides. Ouch, that was painful. And the other side as well. And the last one. So, see if we can find some screws. Here we go. Let's zoom back out a little bit. Can be easier to see. Let's try with one of the $12mm M2 bolts. Feed that in from the bottom up there, and the idea now is, yeah, I'm gonna zoom back in. Idea now is that we will just wrap this nicely around here. Like that. Put on another washer. Like so, and a locking nut. Manage that. There we go. See if we can enter that and fasten it. It's rather fiddly. It's a good manage. We'll hold on to the knot with the pliers and just fasten this as best we can. I think that's going to make a pretty good contact, actually. You see this? Yeah. Yeah, it's starting to slip. These are not really quality tools, I'm afraid, but I think that did quite well. And we'll do the same thing on the other side. 12mm M2 bolt, a washer, go in from below. Take the wire from the coax and wrap it nicely around the screw, about like that. Then another washer and a lock nut. Are we seeing this still? Yeah, I think we are. And once again, we hold on to the knot with the pliers and we fasten it. Let's see what we can manage. That was too fiddly. Let's try this instead. I think this is going to work quite well. Surprisingly well, in fact. This is clearly a way of doing it that we could try again. Are you still seeing this? Let's see if we do this, yeah. And here we go. Nice tight fit. Let's see if we can zoom in. You can see here the wire is coming out of the boom and connects to the radiating elements like that. And the same on the other side. Very good. I think the only thing that remains to do now is tuning the thing. So let me just clean up some of this mess and we'll get right to it. I will spare you the trouble of watching me trying to tune this. So I've done that off camera. I'll just run through what we saw. Starting out, I'm measuring the elements from the center of the mast. That is because the wire going into the coax actually goes into the center of the mast before it goes into the coax, which is the transmission line. So measuring in that way, we started out at 190 millimeters, and that made the antenna resonant at 340 megahertz. So based on well, nothing more than a hunch, I removed 25 millimeters and measured again. That means we end up at 165 millimeters, and that made the antenna resonant at 392 megahertz. So, trying to be careful and not cut too much, I removed 10 more millimeters, ending up at 155 millimeters, which made the antenna resonant at 408 megahertz. And lastly, I removed 12 more millimeters, ending up at 143 millimeters, and the antenna is now resonant on 434 megahertz. So pretty much spot on where we want it for LoRa APRS. With that, I think there's only one thing left to do, and that is to fit the small end caps so that all sorts of crap doesn't find its way into the radiating elements. And for that, we will need even more epoxy glue. So I'll glue up a very, very small batch because very little should be needed for this. And with that, the antenna is going to be finished. And the idea then is to try and compare other antenna designs, especially antenna designs for LoRa APRS on 433.775 megahertz. And the thing is, when you measure the gain of an antenna, you very often you get a number referenced as dBd, and that is a gain relative to a dipole, the D for dipole. Oh, no, this is going to be messy. Let's see. I'll try to get it in the ends instead. So now, when we build antennas for LoRa APRS, we can measure the received strength on them, and we can compare it to the received strength on this antenna. And that way, we can figure out the gain or loss, as the case may be, compared to a dipole, and we can actually get some real numbers relative to the dipole, so dBd numbers. A little bit more scientific than just trying it out and seeing if it works. And so hopefully this is going to enable me to feel a little bit more confident in any sort of antenna design that I try in the future. That was it. We've fitted the end caps. And on the other end, we have a nice SMA connector. The handle is about 50 centimeters long. The thinking there is that I have at least half a wavelength of being out of the way, and I can hold it here, being at least half a wavelength away from the dipole. Or if I want to mount it to a mast to do something a little bit more scientific. That I think is going to have to do for today. If you find this sort of thing interesting, and if you'd like to see me test this, and specifically if you'd like to see me testing this and comparing other antennas to the standard dipole, then please subscribe. If you'd like this sort of build video, I would very much appreciate a thumbs up. And other than that, if you have questions or any sort of comments as to what I've done wrong or what I should have done differently or what I should do next time, then feel free to leave a comment. Other than that, until next time, I would say 7-3.